So I'd like to talk about projectile motion today and just to try to get some of the things from our notes so they make maybe a little more sense. So let's think about an object being thrown or dropped from some height. So if you start here as our starting height, if you throw it up, it goes up, and then this is what happens. It comes down and hits the ground. So there's a couple major points here that we'd like to talk about in terms of what this looks like. So if you throw a ball up, or you hit a baseball, or you have a soccer ball, or if you just throw something else up, into the air. Otherwise, it would look a little bit differently, but it would have the same characteristics. The first thing is that this point over here on the x-axis, let's call it 0a, that y-intercept, the y-intercept is your starting point. Think about it. It's the starting point, and if this is feet or whatever the height is along the y-axis, and this is time, usually in seconds along the x-axis. So height is along the y, and time is along the x-axis. If I had a point like 0a, that would mean that it's a feet is my starting point. At some point, it's going to max out. This is the vertex. The vertex is the highest point, right? It's the highest point on the graph, and there's an x value and a y value. Now think about what's going on here. The x part of the vertex tells you time. It tells you how long it takes to get to the highest point. And the c is the height at the highest point. So maybe it's after 2 seconds, it's at 50 feet or something like that. But we need to know that the time in seconds is the x value, and the height is the y value in the height in feet. And the other important point is down here on the x-axis. I'll call that d0, the x-intercept. The x-intercept, the 0 is our feet because it's on the ground, and the d is that's how long it takes to get there. So maybe it takes 3 seconds or 4 seconds or whatever it takes to get to the ground. But these things play out over and over on these type of projectile motion problems. And the first thing to notice is if you have an x value or a y value, an x value is always in time, and a y value is always in distance, or the height up from some kind of object. So that, to me, if you're asked about a problem, you should be able to answer saying what the story is for this particular problem, right? If this is let's say this is at 0, 20, and this point at the top is at, 150, and this point down here is at, not sure what it would be, let's say 2.50. I'm just making it up. And that this is a projectile motion where this is time in seconds, or it doesn't have to be seconds, it could be hours or minutes or days, but things don't usually stay in the air that long. And then the y-axis is in feet. So in this story, I would say that an object is thrown or hit from 20 feet above the ground. Maybe it's on a mound, or maybe you're golfing off of a building or something like that, right? So you hit something off the top of something that's 20 feet tall at 0 seconds. After 1 second, it's reached the highest point at 50 feet. And then down here, it keeps on going, and at 2.5 seconds, it splats on the ground, and you're back down to 0. So to me, these projectile motion problems are all the same. We need to know the difference between a y-intercept, a vertex, an x value of the vertex, the time, y value of the vertex in feet, or whatever the distance is, if it's in meters or inches or whatever it is, and then the x-intercept again in seconds. Now notice that this parabola, if we did it on a graphing calculator or Desmos or something, there is another x-intercept, but it makes no sense for this particular type of problem because it would mean that you're going backwards in time, which some people might be able to do, but we're not going to be talking about